and Professor of Physics, SNS Technology Coimbatore. Today our case study topic is semiconductor physics. So our students explain about semiconductor physics types and applications and uses. First of all, we start with the types of semiconductors.
So types of semiconductors. Semiconductors has two types, intrinsic and extrinsic. Intrinsic semiconductor is a pure semiconductor material. Example, silicon and germanium. Extrinsic semiconductor is a doped semiconductor and it has two types, N-type semiconductor and P-type semiconductor. N-type semiconductor is a pentavalent atom. Its charge carrier is electrons and its example is phosphorus. P-type semiconductor is a trivalent atom and its charge carrier is holes. Its example is boron.
There are two types, intrinsic, extrinsic. Which one is pure semiconductor? Intrinsic. Then there are types of extrinsic, N-type and P-type. Then majority N-type, electrons, and the minority P-type, holes, minority P-type, electrons. Okay.
So the advantages of semiconductors. Semiconductor devices are very compact and lightweight compared to vacuum tubes. They consume very little electric power for their operations. They have better energy conversion efficiency and faster response time. Since they have no moving parts, they are less affected by mechanical shocks. Mass production makes semiconductors affordable for a wide range of applications. So disadvantages of semiconductors, their performance gets affected at high temperature. Excessive heat can damage their performance. They can handle only limited amount of current and voltage in vacuum tubes. Semiconductor can produce electrical noise which affects their sensitive circuits. Manufacturing semiconductor devices require clean and controlled environments. Exposure to nuclear radiation and cosmic rays can damage semiconductor devices.
Okay. And semiconductor is the most important material in material science. So which one is common property for conductors, semiconductor and superconductors? Or difference between conductors and superconductors or semiconductors? Difference upon the resistivity and conductivity. So basically low resistivities are called conductors, but semiconductors resistivity lies between conductors and insulators. Okay. For superconductors, there is no resistivity. Zero resistivities are called superconductors. Okay. Next, the properties of semiconductors.
Okay, 0 Kelvin. The semiconductor act as an insulator at 0 Kelvin. It lies between the conductivity and the insulators in the order of 10 to the power of minus 14 to 0.5 ohms meter. It shows the negative temperature coefficient at resistance. When the conductive temperature increases by adding the impurities, the process of adding impurities is called doping.
Very good. Next, applications of semiconductors.
Now we will talk about the application of semiconductors in electronic industries used in precision diodes and interface, which are base building blocks for all the electrical devices, computers and mobile devices. Semiconductors are used in microprocessing and memory chip in computers, laptops and smartphones. Communication systems, resistor for the device like radios, television, satellites and mobile networks. Solar cells used in photovoltaic cells to convert the sunlight into electricity. LED and laser device, light emit diodes and laser diodes are made using semiconductors, materials like gas. Power devices, power semiconductors like MOSFET controls and converts the electric power in applications and industrial equality. Medical equality used in imaging devices like MRI, X-rays. Automobiles used in engine controls like serial, cars and automotive vehicle. Home application phones in reflection, watching medicine, and rain correction.
Okay, very good. There are applications